terminologies and architecture that we will be looking into it in next couple of slides. So the first comes with distributed system. We all know that we are working in multiple distributed systems environments. Like every model has been deployed on different physical machines instead on single machine. So whenever the IT industry moving up globally within the business, so they want to distribute. The strategy has come up in such a way to make the resources that they rely on should be distributed, but not to have a dependency on an existing or any one resource. So the distributed systems comes into picture when you have multiple resources. I mean to say, you can talk about any hardware, software that will be residing on any physical machines. Even that physical machines locates in different global zones, different areas, I mean to say. So when we talk about distributed systems, that is nothing but dividing the work among several independent modules. The failure of single module has less impact on overall system. Moreover, to say the system to have more availability, scalability, and maintainability. So this is the main part where the industry has been rolling out in recent days, and to make sure our platform, the software that we are running, is under middleware, and middleware is one of the resource capability area where you have the hosting of the applications, maintaining of the applications comes into picture. So within this distributed systems, our middleware resource is part of it. And when you talk about architecture in the distributed systems, you might be having 1 tier, 2 tier, 3 tier, more than n tier as well. The tier here is nothing but you having different client modules which would be connecting to various resources, which could be middleware or a firewall, or it comes with a hardware load balancer, or which comes with even a database. Even if you have 2 tier which would directly interact between 2 resources, then database comes into picture. Entire when you have client, server, as well as database, then it comes up 3 tier and multiple tiers again. Multiple tiers comes up where something like when you have client interacting with web servers or web containers, again that would be pushing to load balancers. From there, that could be pushing to application servers. From there, it might connect to database. So even this aggregation would really depend on the architecture within your organization. So your architecture would be the right persons to judge what should be the architecture that need to be maintained for certain applications. So if I was moreover to say, the architecture would be defined based on the criticality of the application as well. Assume that if you're working or if your organization has a banking level applications, like I can give you example as any Bank of America, then any site, any website, any banking website. So that kind of websites are being rolled out on internet, worldwide network. So in that scenario, this would be exposed to every client who will be on internet. So in that scenario, the banking site would have a different kind of architecture before actually comes, when the client request actually comes to its own network, its own local network. Like what I mean to say, whenever from your system, when you hit bankofamerica.com, from within internet, it will roll out to different routers. From there, it will be moving to load balancers. Post that, when it's trying to hit to a particular web server or firewall of the Bank of America local network, it would route to different layers. Layers again, I mean to say application layer, transportation layer, data link layer, generic network layer I'm talking about. So when within the worldwide network, so this would be really coming to picture when the Bank of America network comes into picture to categorize the different client requests. Again, locally within Bank of America network, that would be defined, that would be derived or the forward, the route would be done from the file load balancers to multiple web servers. Again, that would be pushed to application servers and the database. So the whole scenario comes into picture when you have the architecture being defined in such a way to handle multiple requests, and the capability of each resource is really huge to make sure all the requests from the global internet would be really being successfully responded to the request that been raised. So the architecture is the main important point that you guys need to know before you work on any of the product or any of the application related stuff. So coming into our own terminologies, let's go with J2E specific and move to Weblogic. So this is what distributed systems, and when you come up with a J2E standard, and J2E standard is nothing but the enterprise edition that helps to overcome distribution liabilities. Again, distributed liabilities is nothing but wherein the support to the distributed environments comes into picture, wherein the development would be done at various categories. Okay, so the standard, there would be certain standards from J2 that we need to follow. Something like the applications, wherein the enterprise archive, web archive, or Java archive, that would be really used to make sure your application is being binded up to follow the standards of J2E and the Java. So there are certain guidelines that you need to follow. So this is purely maintained by the Java developers who really write up the code, and they would really follow the standard they need to follow, in fact, to say, because when they need to really work on this product, the Weblogic server product, they really need to know the kind of applications that they are developing should be compatible to the servers. And every server will have their own respective platforms, the product specific and the platform specific file descriptors that they need to follow. So that's the reason, moreover, to say the developers are and really need to know the capabilities of this application server before they start developing the application server. And moreover to say, and JCP is nothing but Java Community Process. This is an organization where where the Java is really binded with, and the development that really happens purely on the directions of JCP. So whatever they develop in Java, assume that right now we are in the market of Java 1.7, and something around in the next 6 months we'll be getting up Java 1.8. So what are the differences that comes up from 1.7 to 1.8, and what are the new features that's going to be embedded by the Java community is what this process or this organization would really focus. And this is the links that you can really look into what exactly the JCP is, and the organization expectations, how the Java need to be built on. And moreover to say, yeah, let's see this Java Enterprise Edition architecture. Again, this follows by this is the same architecture that would be followed by any of the application server, not only Weblogic server. Any of the application server would really follow this J2E architecture to make sure their applications and the code would be compatible to the Java applications that have been built by the developers. Okay, if you see the left side, the color with blue is a client application. The client applications can be anything. A simple applet application can also be a client application that would be interacting with a particular server. You may also think of web clients, or web clients is nothing but any application that being deployed on the server would be accessed on browsers, so IE or Firefox or Chrome. And the client applications also, you can say something like a McAfee client that you install on your local machines would interact with the servers, would interact with its McAfee server, which is being deployed on any of the application server, that would really send the server code updates for it, client application. So these are the client applications, and the middle tier right now we are seeing is nothing but the where we have Oracle Weblogic server. That's nothing but a J2E application server has its own, again, its own standardized with based on the Java support to various modules. Something like, if you see the containers, the basic two are the containers. The web container and the EJB container are the two major containers which formulates an application server. So when we have these two containers in our middle tier is nothing but an application server which would serve based on their capabilities. So if you see the web container, it would serve the request, and the response would be done based on the client request with servlets and JSP, moreover to say. And any enterprise applications built on EJBs would be served by the EJB container. So these two containers would interact with various services. If you see in the middle tier, the lower level of the screen, you would be seeing various services that's part of support with the Java EE. Certain you can say as JNDI, JAS. The JAS is used for authentication and authorization service. JMX, messaging extensions. JMS, messaging service. JDBC, any database connectivity. JTA, transactions. RMI, remote method invocation, and web services. These are the different services that was being available by any application server to support with your containers. And the middle tier, when interact with other tier, the last tier can be any of the services. Here you can see the database, any of the directory services, nothing but an LDAP, or core bus services. Again, it could be another Java application that's been deployed on any other server. And the messaging queue. Here it talks about IBM messaging queue and the web services. So these are all the services that would be interacting. These three tiers makes up an entire architecture based on the Java standards. So I have certain definitions where I was talking about earlier, where our containers, the middle tier contains two containers I was talking about, web container and the EJB container. So the web container would be handled by the Java servlets. So these are just a definition that I just want to highlight. Okay, so yeah, so the definition itself says it's servlets is a Java program that executes on the server, accepting client request and generating dynamic response. So that's purely on the HTTP response, and request and response code would be delivered, would be created by the Java servlets to make sure our application servers or the web servers or the web containers should respond to the request that been received. Okay. So similarly, JSPs, again, these are HTML documents that are interwoven with Java. So again, the servlets and the JSP basically being built for any response, request and response that would be delivered between client and application server. Okay, next would be the EJB. This EJB is nothing but enterprise Java beans that would be really being served by EJB container within application server. Again, these are distributed components written in Java programming language, provide the distributable and deployable business services. Business logic is really been built on EJBs. So that EJB has been deployed on the Weblogic server. So there are different versions again for EJB support, because for every Weblogic or any of the application server and JDK versions is really should be have compatible to the respective EJB specifications. Again, if you see Oracle Weblogic Server 10.3.1 supports the EJB 3.0 specification. So if you talk about EJB 2.0, 2.1 specifications, that would be supported by the previous versions of Weblogic Server. So we need to also see the capabilities and to make sure the respective application being built on to have certain standards that to be compatible with. So you need to also concentrate on the compatibilities of the Java standards that you're following. And next would be the JDBC connectivity. JDBC is one of the service that I have showed you on the architecture that comes up in entire. So one of the tier would be JDBC database. So when you try to connect to that database, you need a unit that really being called up by the application servers to make sure there is an connectivity to the database for any transaction level. So this JDBC is one of the service, and it's a standard Java interface for accessing heterogeneous databases. Again, you might be having question that database is also being, recent databases have a rack cluster. Right. So rack clustered, again, that's again the category of the database administration that comes into picture, wherein they would really know what and how that would be comes into picture, and how would be in capability to handle the request. So we are really not bothered about the database, but we are really concentrated to make sure that successful call to the database should happen from the service that we have in the application server. Okay, and the specification that defined 4 drivers types for connecting the database. Again, the Java, the Sun provides Sun has its own drivers to make sure to have a successful call by using drivers. And there are certain drivers being provided by the Oracle, by the vendor specific drivers as well. You have Sun specific and you have Oracle specific. So the majorly being used is a type 4 driver being provided by the Oracle vendor itself to make sure to have a successful call to the database. And that driver specification need to be used within the application servers to have the JDBC service to have a successful call to the database. And moreover, to say the database I'm talking about, it can be any database. We can talk about Oracle, which is 80% of the market being used. And we have a DB2, we have SQL Server. And moreover, to say again, you need to have you need to really look into the vendor specific documentation to make sure which database they have been, which drivers they have been used in overall while using within the application server. And JNDI, Java naming and directory interface. Again, this is one of the service being used within the application server. Again, it's purely a Java standards, and it's purely built on Java API for accessing naming and directory services, and built as a layer over DNS, LDAP, and so on. So this is purely to make sure you have a naming and directory interface to interact to get the a certain tree level structure that's been residing on the servers. So the point that I need to highlight here is every server, every Java server, not only Weblogic server, any of the application server would maintain a JNDI tree for every server specific to make sure that the services that gets registered to that server would be displayed on that JNDI tree to make sure that the replication would happen, and the replication contains the JNDI tree replications. So that JNDI naming would really helps in having up an API calls to different layers. Again, different layers, I mean to say, when you have a JNDI named specification being defined for every services, like example I can say for JDBC, and the JNDI name would be the main part that would interact, or that would help the Java applications to interact with respective resources. And the JNDI tree that I was talking about, this would be the way that would be residing on, and it would be identified with its initial context to make sure to have a successful binding for every object that gets created to interact. And JMS, Java Messaging Service, is again a Java standard service that has a Java API calls, Java API being used for an accessing message-oriented middleware. So when you talk about JMS, you have a JMS coming to picture when you have a service residing on any of the application level within the middleware tier. Assume that an application server also has capability to maintain a messaging queue, messaging oriented service. If you don't want to depend on any of the application server based for the service, you can also reside on the third party messaging products like IBM MQ or ActiveMQ by Apache. Within this JMS, again, the interface supports point-to-point domain and publish and subscribe domain guarantee message. These are again the services being interface being supported by the service that we need to, that every application server would really follow the standards. And the JAS is nothing but a Java authentication and authorizations. It's a service again that's been part of Java standards. That's a Java based on a security management framework service being supported. And JAS supports single sign-on and authentication module within by any other sources like IAM and Oracle OAM, OVD, we can say that. And JAS enables flexibility control over authorization, whether it is based on users, groups, and roles. So JAS really depends to have a flexible control based on the categories that's been specified here, users, groups, and roles. Based on this, JAS would really works on. And JMX, Java Management Extensions. Again, these extensions are really used to have control over any of the MBean interaction that we do. So the specification describes MBeans, which are building blocks of JMX. So the management tool really interacts with MBeans residing on the server with the Java JMX extensions with the use of this. And the client application. Okay, right now we comes into the architecture that we really we just spoke some time back. The client applications that I was talking, something like client applications, applets, web service calls, web service client calls that I was talking about, any web client. These calls would really interact with the WLS or any of the application servers through GRMP. This is called a protocol, or T3, IIOP, and JCOM. These are the different protocols that supports based on the Java standards. And T3 is an internal protocol that's within Weblogic that would really interact. And types of client modules are nothing but we have standalone Java applications, applets within a browser. And the web client. A web client is nothing but a web client interacts with any of the application server or the Weblogic server via HTTP using servlets or JSPs. So previously we are talking about that. And the type of web clients includes browser and the web services. And when we talk about proxy servers, okay, again if you see here, web client is again different from the proxy servers. Proxy servers has capabilities to forward requests to other machines. If you see the pictorial diagram over here, the client at the left side would hit first to the proxy server if we have in the architecture. That would really make sure to forward to the request to the different servers, or it can also act as a load balancer to have an equal resources to be distributed to the other part of the resources. And this proxy server can be used as a level of indirect and security. Can be used to load balance as well. And the reverse proxy is a web page cache. We can also use this for this feature as well. And the web server. Proxy server is again different from the web server. Again, you could see the certain similar capabilities, like web servers provide web requests served by them, and it would communicate via HTTP, FTP, and so forth, and can handle CGI requests, and the proxy some requests as well to the application servers. So it has some minute level similarities with the proxy server, wherein it proxies the request to the application servers before hitting. So for this web servers, if you talk with Weblogic, Weblogic would really gives plugins. This is again a piece of code built on C++ and C and C++. That would be really need to be embedded with the web servers to have the request. Instead of web server coming to picture, web server to plugins to come, web server would interact with the plugin code that been derived on it, and that would really interact for all the HTTP and HTTP requests. And the firewall, you generally might know in the real-time in your organization. The firewall is one of the resource to filter authorization and authentication service, and to help to keep out of hackers. Map report requests can act as a proxy servers, can decrease backend network activity. So it would really filter the request that comes onto the resources onto the other side of the architecture. So application servers. Okay, when we're talking about application servers, right now it can be not only Weblogic server, it can come up with any of the other products like IBM WebSphere. It comes with a JBoss, Glassfish, any of the application servers. So every application server is purely Java based, so it should provide this capability having with web container and EJD container talking with the multiple Java based services that we are talking about, like JNDA, JAS, JMX, JMS, JDBC, GTA, and RMI and web services. So these provide services that support the execution and availability of deployed applications and handles heavier processing cores than web servers. So web servers can't act as an application servers, but application server can act as a web server, because the more common container that we have is a web container. So this is a web application server configuration. This is the final architecture that we need to really know how it's been residing overall. When you see here, the client application would interact with firewall, and that firewall would be residing before it interacts with internet. So when you talk about the firewall at the beginning level, that the firewall would also exist on your local machines as well. So that would really interact with internet, and when you go on to beyond of the internet, the vendor specific or the product specific or the organization specific network comes into picture, wherein that would be again protected by the firewall, and that firewall would be followed by the web server. Again, that would be web server would be followed by the app server, and the database, that's an internal network within the organization. And this kind of architecture would be followed for any web applications that been deployed on the application servers. This is general, so it is need to say that we need to have mandatory of this kind of architecture. That would really depend on the architects of your organization who really decides what should be the architecture. And if you talk with application server configuration, if you see the difference over here, you don't have web server over here again. So again, I said it's really not mean to have the web server or the application server for within your architecture, but it's purely depend on the kind of applications that you really depend on. If you have only web applications that really doesn't require an app servers as well, then you might be having architecture wherein the web server would be the final resource that would come into picture. But whereas if you see the only application server configuration, we don't have web server over here, but this application server, moreover, it would interact with multiple application servers. So the application server to application server would be the major interaction over here. So that's it with the basic level for now, and let's pitch in with what exactly that we will be learning in the next sessions. We really have a standard content that we already been shared up. So let's see what are the main points that we'll be talking about for this Weblogic training session. So as I said, the prerequisites is to know the basic knowledge of Unix and the basic knowledge of XML and basic knowledge of networking knowledge. And as major specification, major suggestion would be done if people know Java is well and good, and if they don't, the basic knowledge is required for it to understand the terminologies when we talk about going forward. And because when we go ahead and working on the Weblogic server, we would be deploying certain applications. Those applications are really built on Java. So that's the reason when we modify the Java applications in our training sessions, you need to really understand the concepts or the patterns that we would be writing on. So that's the reason we recommend people to know the basic knowledge of Java. And the course objective. Okay, what we are expecting, I'm saying, what is the objective of this course? Majorly to say, at the time of completion of this course, you should be able to know the description of the architecture of the Weblogic server, domains, servers, machines. These are the topics that we'll be talking within the Weblogic server training sessions, and a basic level again of the product, like installations, configuration, troubleshooting. I'm saying we'll see all these aspects over here, and perform regular administration functions as well for Weblogic server, and we'll also learn how to set up a cluster for the servers that we'll be talking about, and the distributed applications and the resources to the cluster. And we also see the configuration with Oracle HTTP server. That would be really the same pattern of Apache, because Oracle HTTP server has been really built based on the Apache itself. So we will also see Sun1 web server over here as a web tier in front of the Oracle Weblogic server. It's just a cluster, and we would be deploying different type of applications, and that's purely built on Java specifications onto the Weblogic server. And we also see how do you monitor. There are different monitoring aspects that we would be doing from GUI level, command line, and also the scripting part. We have on WLST is a default scripting that we have within WebLogic, same as WL was admin for WebSphere. And we'll also see how to deploy and manage large-scale applications and its life cycle. And we'll also see basic resources like application security and JMS also be part of these training sessions. So we'll also look into it. And moreover, we'll also see a high-level backup and recovery. How do you do when there is a failure exists in your middle tab? Okay, course description. So let's see the detailed description over here right now of the course content. Moreover to say, basically, when we start with the Oracle Weblogic server product, we'll see the installation of the Oracle Weblogic server is one of the topics that we'll be starting with, to know how and when the basic and the flexibility, the kind of mode that we used to install, like GUI mode, command line mode. We also have one more mode called silent mode, which makes sure feasibility to have and flexibility. That silent mode also we'll have a look into it when we're working on it. Once we are done, we'll be learning how to see the directory, what exactly the directory structure of the software. Once we are done with that, we will be working with configuring a simple domain. Again, domain is nothing but a workspace for any IDE. So it's a kind of similar way. We'll have a space, a domain specific space, wherein we'll work around for an Oracle Weblogic server to be configured. So in the same pattern, we'll configure a simple domain, and that domain will be working with different managed servers and admin server. These are the servers definitions that we would be creating up when we creating up the domain, and we would understand the directory structure of the domain, and also we'll also see how do we manage the domains with WLST. WLST, as I said, it's a WebLogic scripting tool. We also have an option to control or to evaluate it by the for the domains to create, manage, and also create a specific level domain configuration that we will be seeing from WLST as well. And while creating up the domain, we need to make sure a certain level configurations that we need to configure, like port numbers and the components that we need to really required while creation of the domains. And we will be seeing creation of the domains using templates. Templates is nothing but these are the pre-existing templates, domain templates that can be used. Or also we can create a domain and we can create a template of our own. That's called a custom templates, and we can use that custom templates to create a domain again. Once you create the domain, you'll have an admin console. This is again one of the discussion that we need to talk about. It's a web, it's a web-based client console that we can really use to make sure to administer the WebLogic server. The same whatever you do on the WebLogic console can also be monitored, or can also be used to configure with WLSD as well. And the next topic comes up: how do you configure managed servers? How do you configure node managers and the logging level? Different logs that helps us to troubleshoot for our WebLogic server environment. Once you see with that, we'll be working with the deployment concepts. Deployment, as I said earlier, we have different kind of applications, extensions, I need to say. So extensions is nothing but extension with the .ear, .wat, .jar. That kind of applications would be deployed on the WebLogic server. And we will also see how they can be deployed, how to test on it, how to set the role when the role comes in. Role, I mean to say, role of a web service. When the role of the web service comes into picture, how do you access those applications with the plugins? We also see those patterns. And deploying J2E applications. Here, when you deploy these J2E applications, we'll be seeing deployment descriptors of a particular specific applications that been built on, something like weblogic.xml and web.xml and weblogic application.xml. We don't see the descriptors at that moment during the training session. And the advanced deployments, and we will also talk about the clustering feature that we have in any of the application server, and we'll learn how do we do that clustering in WebLogic servers. And the JMS resources, how do we set up JMS resources, and what do you do for configuring, deploying, and monitoring several services. And we also see the security concepts as well. How do you configure, how do you protect your WebLogic server, how do you protect your web application resources. And we also see SSL configuration as well, one-way SSL, two-way SSL. We'll create certificates, we'll deploy them on the WebLogic server as well. And at last, we would see the backup and recovery operations. This is a high level again. That would be helpful for us to make sure that if any failure occurs, we can recover from these features that we have. So that's all I have for. Let me know if you have any questions.